Welcome to the 2021 Virtual Materials Research Society Spring Meeting. We are going to have a full week of live symposium sessions, keynote and award talks, a dynamic and exciting virtual exhibit, and much more. This is MRS TV. Welcome to the 7th and final episode of MRS TV. We hope you have all enjoyed this 2021 spring meeting and encourage you all to go check out the previous episodes of MRS TV on both the meeting platform and on YouTube if you missed out on any of the previous programs. For our last episode, we are joined by MRS Spring Meeting Chair Andreas Lendlein. Andreas tells us about all of the work and challenges that went into making the MRS Spring Meeting and some words of encouragement for others looking to get involved in future meetings. First, though, let's look at the highlights from the last day of the MRS 2021 Spring Meeting. Friday features a final full schedule of technical sessions. We also have another Symposium X keynote talk titled How New and Old Materials Research and Know-How Extend the Increase in Computation Power. And we would just like to remind you that all of the live sessions throughout the week have been recorded, and you can find those by searching through the full agenda in the Symposium menu on the meeting platform. We now welcome MRS 2021 Spring Meeting Chair Andreas Lendlein. Welcome and thanks for joining us, Andreas.
Thank you. It's great being here.
Well, Andreas, at long last, the meeting that you have been working towards for several years is now here. This certainly wasn't the typical path toward an MRS meeting. Can you tell us about your journey that you took as a meeting chair to get to this day?
No, initially, we were thinking we might be the first meeting that is a present meeting again. Then it became a hybrid meeting. And finally, we ended online, which was difficult for all of those who already had contributed their abstracts because they were planning to travel to Seattle. So we really needed to get at some point the message out, this will be a full online meeting and there will be special opportunities to participate in this. As of today, we have more than 3,000 participants registered for the meeting, for an online meeting. That is a tremendous success.
Well, there is a lot of work involved in being an MRS meeting chair. Why did you want to volunteer for this role?
First of all, of course, it is giving back. I mean, I grow up as a material scientist with the MRS. You have your first poster presentation, you get your first invited lecture, you are in symposium organizers, and then you develop this idea, wouldn't it make fun to also be a meeting chair? But the other mission that I felt that could be realized, and that was to demonstrate how materials make an impact in our today's life and how important they are for our future. Because our world is changing. We have the climate change, we have societal changes like an aging society. In all of these areas, materials will make a difference in healthcare, in sustainable energy, but also in consumer products.
What advice would you have for future MRS meeting chairs?
If it stays an online meeting, there are a few things that we learned. First of all, it is important to have as many live sessions as possible. We tremendously extended the time that is available for live discussions. And the other thing, and I'm sure most people who have attended in the last year in online events know, is we need to pay attention to the different time zones. So we have participants from all over the world, from Australia, Asia, Europe, US, all areas. And therefore, a live session that is given in the morning in Asia might be very difficult for somebody being at the East Coast and participating. The other thing is, also in the future, we need to be open-minded, take up new topics, but also pertain the successful areas of the MRS.
Obviously, the pandemic has had a drastic effect on the meeting, but for you personally, how has this affected your day-to-day work?
One of the major changes we experience right now, so this interview is now a video conference. As an institute director, the task to manage the work in the lab so that we only have a limited number of persons working at the same time in the lab. And before that, pandemic time, I traveled a lot to conferences to meet other scientists, and now I'm not been in an airplane since almost a year.
Andreas, thank you so much for your time today.
It was a pleasure.
There are a number of initiatives around the country and federally to decarbonize our energy sector. And this is a huge challenge if we consider the amount of petroleum and natural gas that we use. One of the ways that we can try to decarbonize some of these energy sources is to consider hydrogen as a replacement for natural gas and petroleum.
Hydrogen is the future. Actually, I think hydrogen has every potential to really revolutionize the whole world and really change the way the world operates right now.
Part of this effort to look at decarbonization is something called H2 at Scale, which is a Hydrogen and Fuel Cell Technologies Office initiative to look at the potential role for hydrogen in the broader energy sector to support everything from transportation to manufacturing to even supporting the electrical grid. And there are a number of different initiatives under H2 at Scale, one of which is the Hydrogen Materials Compatibility Consortium called HMAT.
In order to have a robust infrastructure, we need to have materials that are compatible with hydrogen. And HMAT is allowing us to be able to look at the effects of hydrogen under high pressure, extreme atmospheres that these materials would be subjected to. Our program is looking at how we might be able to make these materials more robust and more reliable in our hydrogen infrastructure by understanding these mechanisms that hydrogen play within the materials.
HMAT does a really good job like bringing multi-national lab efforts so we can really leverage unique capabilities and resources from different national labs.
While Sandia National Laboratories in California and Pacific Northwest National Laboratory are the two leads of the HMAT program, Argonne National Laboratory, Oak Ridge National Laboratory, and Savannah River National Laboratory are also contributors to this HMAT effort.
At the Pacific Northwest National Laboratory, we're currently focusing on the polymer side of this effort. In contrast with metals, polymers have been less studies, and there are very little of literature research down in the polymer side.
We use these materials as barrier liners, whether it's in a high pressure vessel to store hydrogen, whether it's in a hose liner, so you could refuel a vehicle or transport it from one container to another, or sealing with an O-ring in a valve, or a compressor, being able to resist the changes in its material properties as it's changing pressure from one stroke to the next under different temperature conditions. All these materials need to be stable and reliable during operations in hydrogen atmospheres.
We have this very new and advanced capabilities called In-Situ Tribometer that really measures the friction and wear, and especially tribological performance of polymers in situ in hydrogen, because hydrogen is hard to measure after postmortem. So we can really understand real time how material performance and how they wear, how they damage in hydrogen in the dynamic situation.
The scientists here want to understand the reaction with the hydrogen with their polymers, so we use ion microscopy to help them understand the issues with hydrogen with their materials. One reason we use the ion microscope over the electron is that we can neutralize the charge effect that the polymer has in a scanning electron microscope with electron flood gun. And the ion microscope gives us a little better channeling contrast so we can understand some of the light elements that are present in these polymers.
We also look at cryogenic materials testing down to 20 Kelvin so we can understand how the material behaves in both composites and resin systems and metals in a hydrogen environment that's for liquid hydrogen storage or cryogenic compressed.
One of the capabilities that we have at Sandia National Labs in California is a laboratory we call the Hydrogen Effects on Materials Laboratory. And in this laboratory, we have some very unique capabilities where we can do fundamental mechanical testing in situ in very high pressure hydrogen environments. So we can do standard fatigue and fracture type testing that industry does every day. We can do that testing within a hydrogen environment at pressures in excess of 100 megapascal, which is a pretty high pressure. In addition to some of the experimental capabilities, we also have extensive computational capabilities because the national labs have access to some of the most powerful computing facilities, looking at these phenomena from a very high fidelity level, even at the atomistic scale.
Nations around the world are aggressively pursuing hydrogen technologies as a way to decarbonize. HMAT labs have been leading materials compatibility research for decades and have formed many strong partnerships with other labs, companies, and universities worldwide to inform our work. We are always welcoming new partners and want to coordinate our research activities with them, since decarbonization is a global imperative.
I'm very excited to be working on this project because I believe the hydrogen can really change the way this world operates. And in many years, I might be able to tell my friends and my family, even my kids, that I'm part of it, making it a reality. Now it's just really changing the world.
That's all for the 7th and final episode of MRS TV. We thank you all for joining all of the great sessions, presentations, and special events the MRS Spring Virtual Meeting had to offer. Please remember that you can go watch any of the recorded programming by searching the full agenda section on the platform, and you can watch all of the MRS TV episodes on the MRS TV playlist. Have a great 2021, and we will see you next year.